So direct mail advertisers send solicitations, also known as junk mail, to thousands of potential customers in the hope that someone will buy the company's product. The acceptance rate is usually quite low. Suppose a company wants to test their response to a new flyer and sends it to 1,000 people randomly selected from their mailing list of over 200,000 people. They get orders from 123 of the recipients. Create a 90% confidence interval for the percentage of people the company contacts who may buy something. So, all the conditions, okay, independence, yes, random, it says it was random, 10% condition, 1,000 is certainly less than all the people, even within their list specifically. And success, failure, that's going to end up being that because it's over 1,000 people. So conditions are met. So we need to find P hat, which is going to be 123 who got it out of all the people who received the flyer, which was 1,000, which is 0.123. Now, I'm going to show you how to do it out by hand, but then I'm also going to show you how to do the calculator. So confidence interval is equal to 0.123 plus or minus. It's a 90% confidence interval, which I don't know if it's necessarily written anywhere, but that is 1.645 is the Z star for 90%.
How'd you know that?
It just a known fact. There's a couple of them that we'll use more often. Anyways, that you'll know. But the calculator will do it for you, so you won't actually have to do it. But I'm more just showing you, so if you see it written out, you know what it is. And then the square root of P hat Q hat over N. So 0.123, 0.877. all divided by 1,000. So we could solve these two separate equations and get our confidence interval, or we can do it in the calculator using the function stat test alpha A, which is 1 prop Z interval, and then calculate. So 1 prop Z interval, it'll ask you for your number of people who like did whatever, or number whatever, 1, 2, 3, so 123. Then it'll say something about the total number that you're dealing with, and then it'll ask for the confidence level that you're looking for, which is 90% or 0.9. And so when you type that in, it'll give you a parentheses with 2 decimal numbers. And so you can either leave them as decimals or change them to percents. But you can put that in the calculator and make sure you know how to find it and everything.
Oh wait, no.
I'll say this shouldn't be point, it should just be 1, 2, 3, like 123. The first value that you put in. It's doing it as if you haven't solved it yet.
Okay. Oh, that's what I did. So 0.10592, comma 0.14008.
Okay, so I'm just going to round it like that. So you can either do it as decimals this way, or what you're ultimately going to use when we're writing the conclusion would be that that's 10.6% and 14%. So then to explain what this interval means, based on the sample, I am 90% confident that the true proportion of people who will buy something after receiving a flyer is between 10.6% and 14%. So then it wants us to explain what a 90% confidence means. And so we can say that if we sample many times, now this one was of size 1,000, so we would say of size 1,000, because it might be different depending on the sample size. 90% of the intervals created will capture the true proportion of people who will buy something after receiving a flyer. So if we ran this basically 100 times, 90 of the times the interval would capture the true proportion, basically is what that's saying. So then the company must decide whether to now do a mass mailing. The mailing won't be cost effective unless it produces at least a 5% return. What does your confidence interval suggest? You think they should do it or not? Meaning that they want at least 5% of people to actually make a purchase if they're for it to be cost effective.
I don't think they need to do that because it's already between 10.6 and 14.
Yeah, but it's saying they did it on a sample to see if it will work on the whole population. But they will only do it if it's at least 5%. This is a bigger than 5%, right? Okay, so then they should do the mass mailing because it's going to produce more return than even what they want to see.
Okay.
So they should do a mass mailing. Because they should expect more than a 5% return. Since the interval is above 5%. Now, if they had said that they only wanted to do it if they were going to get a 15% return or that was the only way it was going to be cost effective, they shouldn't do it because our percentages were only between 10.6 and 14%. But as long as whatever they are seeking is in our interval, we can say that they can proceed, basically. All right, so a study of 902 decisions made by the Nebraska Board of Parole produces the following computer output. Assuming these cases are representative of all cases that may come before the board, what can you conclude? So it has the z-interval for proportion with a confidence of 95% confidence, gives us out this interval. Okay, this is just how it would look instead of it coming out of the calculator if it came out of like a computer program, because you can do all this stuff like in Excel. And well, I don't know how, but you can. I'm really bad at Excel. So basically this is saying that our interval is 56.1% to 62.5%. So just to conclude this, based on the sample, and we don't have to know anything else, based on the sample, I am 95% confident, because that's what they used, that the true proportion of inmates who are paroled by the, and I'm just going to abbreviate it, NBOP, is between 56.1% and 62.5%. All right. A May 2007 Gallup poll found that 11% of a random sample of 1,003 adults, that's really annoying, that's not even a number, approved of attempts to clone a human. Find the margin of error for this poll if we want a 95% confidence in our estimate of the percent of American adults who approve of cloning humans. So we're going to use our formula for margin of error, which is Z star times the square root of P hat Q hat over N. Do you remember what Z star for 95% is?
No.
It's 1.96. So this is going to be 1.96 times the square root of, so P hat is the 11% here, so 0.11 times Q hat, which was 0.89, and then divided by the sample, which is 1,003. You'll have to multiply that out and see what that is. You do know the calculator's right in front of you, right?
Yeah. So the product of the equation is 0.019.
or we can call it 1.9% also. So it wants us to explain what that margin of error means. So we can say, I am 95% confident that the true proportion is within 1.9% of 11%. Okay, because that's what the margin of error is telling us for cloning humans. So the margin of error tells us how close it's going to be to the percentage that we're given to start with for a certain confidence level. So C and D, the questions are kind of backwards. Because C says, if we only need to be 90% confident, will the margin of error be larger or smaller? And then D says to find it, meaning for the 90%. So I'm going to find it first, and then we'll answer part C. So the margin of error for 90% confidence, and 90% confidence is 1.645. So margin of error is equal to 1.645 times the square root of, and then the stuff inside stays the same. So 0.11 times 0.89 divided by 1003. And so then I want to know what that comes out to be. So that obviously is smaller than the 1.9% that we got. So it's smaller because we are less confident. So being less confident is going to make our number smaller. If we change it to like a 98% confidence, then it would be larger. All right, so next one. The mayor of a small city has suggested that the state locate a new prison there, arguing that the construction project and resulting jobs will be good for the local economy. A total of 138 residents show up for the public hearing on the proposal, and a show of hands finds only 31 in favor of the prison project. What can the city council conclude about the public support for the mayor's initiative? Any ideas? Or are there any problems that you might see with how they're going about this?
As a whole, they're not confident in the project.
Yeah. So overall, not much. Because the sample is not from a representative sample. Meaning that it's not random, which is one of the conditions that has to be met. So conclusions may not reflect the opinions of the public and there's a type of bias to this. Do you happen to know or remember what type of bias this would be?
That was so long. I forgot the types of bias. Was it like figurative bias?
No. Well, maybe not so much the name, but what if you had to explain the type of bias that you could see here, what would you see as being a bias about this particular way that they were going about this?
So it's not a simple random sample.
There's one.
That's what I remember. But yeah, I'm stuck.
So this would be a voluntary response bias. Because the people that show up to the hearing are probably people that have a very strong opinion. And typically only the people with a strong opinion are going to say anything. Now, you might get a few random people that just show up to everything. But this right here is a problem. Or is the problem with this whole thing. All right, so then number 8. In preparing a report on the economy, we need to estimate the percentage of businesses that plan to hire additional employees in the next 60 days. How many randomly selected employers must we contact in order to create an estimate in which we are 98% confident with a margin of error of 5%? So this is one of those where we have to figure out the end value of what our sample size should be. Now, just because I don't expect you to know these, and what I'll do on the test and stuff are the ones that we don't use a lot, like 98%, and one of the later questions on here, it's got a 99% one. I would give you those on the test if you need them. So 98% confidence is 2.326. So we use the formula for margin of error, which is ME is equal to whatever our confidence level Z star is, and then the square root of P hat Q hat over N. So I'm solving for N. So 0.05, because margin of error is 0.05, is equal to 2.326 times the square root of P hat Q hat. It doesn't tell us, so remember when they don't tell us, we're assuming it's 50-50. So 0.5 times 0.5 divided by N. And then we just have to solve this equation. So I need to divide by 2.326. I'm just let you do that because I certainly cannot do that in my head. And then you'll have to square that value and then do 0.5 times 0.5 divided by that value.
So 0.05 divided by 2.326.
Yeah.
0.2.
And then you'll have to square that number. Okay, so that's like 0.0004 or something. But then do 0.5 times 0.5 divided by that number. So if you do 0.5 times 0.5 and then do the divided by and then hit second and then the answer button at the bottom, you won't have to rewrite it. It'll just do it.
We got 566.893.
You said 566.
0.893.
So I would just round that up to 567 businesses. So in general, if we were going to find this formula to solve for n, we would have the margin of error divided by z star squared. Hold on. Do this. And then p hat, q hat. So p hat, q hat divided by that would be like the general form. But, I mean, I usually think it's easier as long as you know how to solve for a variable, which by this point in your life, I hope you know how to solve for a variable. That you wouldn't really need that, but some people like to just have the formula in front of them, which is fine. But that's how we would find it. And like the answer that you get might be a little off from the book if you're solving for it because they may or may not round. So like my answer that I had was like 540 something, but if you don't round or you do round, your answer will change a little bit. So don't be alarmed if you're like a little bit off, because odds are that's why. So suppose we want to reduce the margin of error to 2.5%. What sample size will suffice? So if we cut the margin of error in half, what happens to the number of people if this number is cut in half? It's changed by a factor of what?
Half.
But that number is ultimately getting what?
Smaller.
What's ultimately happening to that number? If it's changing by half, it's
Oh, it's double.
squaring.
Same thing.
Squaring, so it's going to end up being 4 times as many people. And so then we just have to do 567 times 4. And I don't know what that is off the top of my head. 8, 6, 2,268, I think, people per business. So then why might it not be worth the effort to try to get an interval with a margin of error of only 1%? Basically, it's going to cause the sample size to be too big. Because that means that we're going to need, it's a fifth as big if we're doing 1% as the 5% that we initially started with, meaning that when we square it, it's changing by a factor of 25. So we went from 567 to whatever that number is times 25, and that's just really, really big. So we would need 25 times as many people as we did for a 5% margin of error. So it's not likely that we would be able to do that, basically. So then editors of the business report are willing to accept a margin of error of 4%, but want 99% confidence. So how many randomly selected employers will they need to contact? So we're doing the same thing, but for 4% confidence and for 4% margin of error, 99% confidence, which 99% confidence is 2.576. So we would have margin of error 0.04 is equal to z star, which is 2.576 times the square root of 0.5 times 0.5 divided by n, and then you just have to solve that again.
So I divided the square. What I do?
Then you swap the n and the number, so you would do 0.5 times 0.5 divided by whatever you got from that squared number.
Okay. I got 1,036.84.
So I'm going to round up to 1,037 businesses. Yeah.
Yeah, I'm gonna do it. Hold on.
Get back here with that chair, that chair. All sorts of cars go on the wing side. Oh, and they have to be lined up. It's like, Peter, what's it? You tried just to print something? Well, you did something. I did something. All right, you can print this again.
All right. A newspaper reports that the governor's approval rating stands at 65%. The article adds that the poll is based on a random sample of 972 adults and has a margin of error of 2.5%. What level of confidence did the pollsters use? So basically, we're finding Z star in the formula now. So margin of error is going to be 0.025 is equal to Z star is what I don't know, because that's the confidence level, times the square root of 65%, so 0.65 times 0.35 divided by n is 972. So basically, you need to find this number and then divide 0.025 by that.
I got 106.8.
You did 0.025 divided by that.
Yes. Wait.
Do you take the square root of this number?
No, I didn't.
I was like, it's a little far off from what that answer should look like, because it should be something along the lines of a number like this. Like 1 point something or 2 point something.
I got 1.6.
Is there any other decimal to it? Or is it just 1.6?
Yeah, I mean, it's 2 zeros after that.
Okay. So, approximately 1.6. So, then looking at our confidence level, okay, 95% is 1.96.
Oh, I got it.
So, which confidence?
90%.
Yep, so this is going to be an approximately 90% confidence level. So with these ones, it's like, what is it closest to? Again, depending on rounding, it might be a little closer, a little farther off, but we're trying to find approximately what it is. Okay, one more. All right. In 1998, a San Diego reproductive clinic reported 49 live births to 207 women under the age of 40 who had previously been unable to conceive. Find a 90% confidence interval for the success rate at this clinic. So I'm going to write out by hand what it would be or how it would be found, but then I'm going to just have you do it in your calculator to actually get the value. So it would be the initial values of 49 out of 207, plus or minus, we want a 90% confidence, that's 1.645, times the square root of p hat q hat over n, so that's going to be 49 over 207 times 158 out of 207 divided by 207. And then that would give you, if you solve it out, that would give you your interval. But calculator can do it for you, so you're going to use the 1 prop z interval of 49, 207, and 0.9, and then get your interval that way. And I guess we should have noted that the conditions are met. But, eh.
Got 0.188 and 0.285.
So that means 18.8% and 28.5%. So then, based on your interval, or interpret your interval in the context, so based on your sample, or based on the sample, about 18.7% to 28.4% of women who previously were unable to conceive now are able to. Explain what 90% confidence means. If we repeatedly sample exactly the same way as above, or exact same way as above, %, of the confidence intervals created would contain the actual % of women who can conceive So do these data refute the clinic's claim of a 25% success rate? So since 25% is in the interval, it is possible the clinic can help 25% of women conceive after treatment.